Hello everyone! In this video I am going to go over some homework on boxplots and percentiles and percentile ranks. So here is the file and here are the instructions. So for number one, this file is actually the data from our class survey, but what I've done is I've filtered a few quantitative variables into different categories according to one of the qualitative variables. So I took hours of sleep during the school year, and then I separated it out by freshmen and sophomores, and then juniors and seniors. So when you look at these tables here, each row is not one person. It's just like, this is just the list of all the freshmen and sophomore, and then this is all the list of the junior and senior hours of sleep. And the same deal here. This is the female heights and the male heights. And then I did video hours per day according to people whose worst grade was an A or a B, worst grade was a C, and then worst grade was a D or an F. So we'll see if they have any differences in how many hours a day they watch videos for. Okay, so first of all, we're going to select columns A and B. So just click and drag from A over to B, and then we're going to insert a box plot. So it should be under the statistical charts area, and it looks like this. All right, and then we're going to just make a couple little tweaks to it so that we can read it and interpret it. So I want to definitely add a legend to it. On the Windows version, I'm going to go to Format, or maybe it's Chart Design. Yeah, Chart Design. And then Add Chart Element. If you're on the web version, I think you click on the chart and then there's like the 3 dots menu or something. Mac people, I totally have no idea. And then I usually like to make these like a little taller and thinner like this to make them easier to read. Okay, so there's other stuff here, like you can delete this one at the bottom, delete the title up here, just makes it, oh, not the whole thing. I just wanted to get rid of this title that doesn't actually say anything. Okay, so now the blue box plot here is for the freshmen and sophomores, and the orange is for the juniors and seniors. Okay, so the questions: how many hours of sleep do the middle 50% of freshmen and sophomores get? And then the same question for juniors and seniors. So the middle 50% of the data is the box itself. So that is going to be between, you can see the actual number if you hover kind of like right, you have to get it right in the right spot, like right over the line. Yeah, you see my little tooltip there is saying 8. I mean, you can just read it off the side over here as well. And then this one is 6. So for freshmen and sophomores, why is this not updating quickly? So they get between 6 to 8, the middle 50%. And then for juniors and seniors, it's between, let's see, this looks like 6 to 7. Okay, so like not enough for either group. You guys should get more sleep. And then second question, what does it mean that the second box plot has shorter whiskers than the first? Yeah, so the whiskers are these lines, and that is where the lowest 25% of the answers are at. So they're between 3 and 6 for the freshmen and sophomores, the lowest answers. Whereas for the juniors and seniors, the lowest 25% of the answers were between 5 and 6. So basically, it means that the freshman and sophomore answers for the lowest 25% and also for the highest 25%, they're more spread out. They're covering a higher or larger range, you could say. So a longer whisker means the lowest 25% and the highest 25% of data are more spread out. That's the general concept. Okay, so now we're going to do this for columns D and E. So I'm just going to move this, like, maybe I'll just delete this because my spreadsheet's already being kind of slow. So we'll do D and E, and we'll insert box plot again, and then we'll add a legend and kind of style it like we did before, just make it a little skinnier and taller so it's easier to read. This over here, get rid of my title, add a legend, Okay, so this was the male heights and the female heights. As you guys can see, they're still kind of hard to read, like these are pretty small. So I am going to actually change this axis to, and I did put this in the instructions, change the vertical axis to show numbers from 55 to 105. Excel defaults to go from 0 to up to the max, which is generally good for most purposes. But for this one, I think it's fine if we zoom in on the data a little bit. So we'll go from 55. So all I did was just right click on the axis numbers, and then I did format. And then I know that's accessible online as well. Sometimes you have to click in some different spots, as you guys already know. You have to kind of look around a little bit for the menus and stuff. Okay, so 55 to 105. All right, so we can see this a lot better now. And let's try, let me move this down a little bit. Okay, so are there any outliers, and what are there? What are they? So the outliers are shown in Excel with these little dots that are outside. So there is one, the student that said they were 8'7" or whatever. That's one outlier for the male heights, which is the height of 103.5. So for male heights, we have 103.5. And there's also an outlier on the lower side. So someone who's a little bit shorter, 62 inches. So 5'2". So those are the two outliers. And then for the female heights, we don't have any outliers. All right, so the next question is, how tall are the tallest 25% of female students? And the same question for the male students. So for the tallest 25%, we're just going to look at the upper whisker, and we're not going to look at the outlier because that person just, I mean, they're really not telling us much about like the data that we actually want to know about. So we're going to just look at the whisker range. So female students between, okay, so it looks to my eyes like the lower whisker for the women students is 60 to 63 maybe. Yeah, if I hover over it, it's 60 to 63. And male students, male students are going from 65 to, looks like 69. Yeah, 65 to 69, so a little bit taller, as you would expect. Okay, number 3. So I'll go ahead and delete this one too. Number 3, select columns G, H, and I. So this is the video hours per day. And insert a box plot. And we're going to add a legend again. I wasn't sure if this would actually show any difference, but it kind of does, actually. I was like, oh, maybe there is some correlation here, but we haven't gotten into the correlation part of the course yet, so we can't speculate too much. Okay, so let me put my legend top. Okay, so there's a bunch of outliers, but you do see some kind of general differences between these three groups. So worst grade A and B, those students are on the left. Worst grade C are in the middle. There's a bunch of outliers. And then worst grade D or F are on the right here, which is generally the most spread out group. So there's people in that group that watch 0 videos, and there's people that watch up to 7, and then an outlier at 14. I assume that's during the summer. I hope that's during the summer. Okay, so what does it mean that the middle box plot has no center line? Yeah, so if you look in the middle box plot here, there's no center. We see the X, which is where the mean is at, but we don't see the center line. So what's going on there is the center line is on top of either the top line or the bottom line, and we can't really tell which just from looking. Yeah, we would have to actually, I think, calculate Q1, Q2, and Q3 and see what the values actually are to tell which one it was on top of. But that's why that's like that. So it means that, so either Q1 equals Q2 or Q2 equals Q3. In other words, 2 of the lines are right on top of each other. So what that means is that that 25% of data that's supposed to be between, quote unquote, between those 2 lines is actually just right at that value. So there were like a whole bunch of people that just gave the same answer. 25% of the people gave the exact same answer. Which was presumably either 2 or 3. I'm not sure which. All right. In the first and third box plots, which is greater, the mean or the median, and why do you think that might be? Not from a perspective of like people watching videos, like why do they watch so much videos, but like looking at the numbers, why is it like that numerically? So the first and third box plots, the x is the mean, and that is higher than the median, which is that center line in the box. So the mean is higher in both cases. It's higher in both. And then why it might be numerically, this tends to happen when your data is skewed to the right or it's skewed towards the greater numbers. And that can happen if you have a long right tail or long tail that's for higher values, which actually we do kind of see from that longer whisker on top of both of these. So the higher values, the highest 25% of values, are a little more spread out than the lowest 25%. And then we do also see they have a pretty extreme outlier in both of those data sets. So that outlier itself, since there aren't that many data values in both sets, even a single outlier could drag the mean up a little higher than the median. So it could be because there's a longer right tail, and there's a pretty extreme outlier in both data sets. Okay, so I'll just put in parentheses here, like what I mean by right tail is that's the top whisker. So the kind of, if we were looking at a histogram of this data, I think we would see a longer right tail. In fact, we could look at a histogram of it. Let's just see if that's correct. Yes, so this one over here on the far right, that's not a tail, that's the outlier itself is in that bin. And then we don't see any left tail, like there's nothing to the left of the modal bin. And then we have kind of this short, very fat, like right tail area here with this column and this column. And then there's no left tail at all. So yeah, this is definitely skewed right, which you're going to see the mean be towards the right, in other words, towards the higher values. Okay, I'm sure we probably see the same thing with the other data set. All right, so number 4 and 5, we're going to do some formulas. So I think I'm going to move this, I'm going to delete this box plot. Oops, I think I deleted a data value just now. Let me undo that. Excel is being very slow to me. Okay, I'm going to move this over here, and I'm going to delete some of these instructions so that I can read this more clearly. All right, so in cells L1 through M4, which are over here, these cells, use the formula equals percentile.inc to calculate the 25th, 50th, and 75th percentiles of the female and the male heights. And they should match the box plots. Oh, maybe I should put the box plots back later then. Okay, so I put the percentages here for you guys' convenience. And then what we're going to do is we're going to use equals percentile. Make sure you select the right one here. It's percentile, not percent rank. And then we're going to do the INC inclusive version because that one never gives us an error. Okay, so I use tab to auto-complete that. And then for array, that's your data. So if you go over here, this is for female heights, you can click and drag from the first one down to the last one, or I'll just go to the bottom of the table. If you do that, what you'll see is the reference that it actually puts in is this table 2 square brackets female heights. So you can put it in that way as well. Okay, and then that's the array, and then the comma K, that is your percentage value. I don't know why they call it K and not P. They should just call it P. But we're going to click on the 25% there. And then the secret to Excel formulas is even if you leave off the closing parenthesis, it'll still let you do it. So you can just hit enter at this point. Nope. But you always have to close those square brackets. Okay, so that's the female percentile for 25th percentile. And then let's do it again for the 50th percentile. Or we could just use the median formula, I guess, but I'm already doing it this way. So percentile.inc, and then I'm just going to type table 2, square bracket, female heights, close square bracket, comma, click on the percentage, hit enter. Okay, so that's a little bit taller, so that makes sense. And then just one more time, I'll do it for 75th. So this is table 2, bracket, female heights, close bracket, comma, 75%. Okay, so that was the female heights. And then I wonder if can I just like fill these over here like that? No. Okay, so I have to do this again for the male heights, but they don't take very long if you do it with your keyboard. 2, bracket, male heights, comma, and then we want the 25%. You guys can also see the formula up here as I'm typing up above the spreadsheet. Okay, and then percentile.inc, table 2, bracket, male heights, and then I'm using the tab key to insert those. Click on the percentage. Oops, I clicked on the height instead of the, okay, so when I go back, so if you want to edit this, double click into it, and then see where I clicked on the wrong cell here, you can actually click and drag that outline to the right cell, or you could just edit the formula, the text of the formula. Okay, and then maybe I'll just, can I fill that one down? Oh, that one worked. Okay, so I was able to fill that one down. All right, so we see these percentiles. So this is Q1, Q2, and Q3. For the women are all a little bit shorter than the male versions, which makes sense. And then they're in order as well. So the 25th percentile is less than the 50th, which is less than the 75th. And these do look like heights that could be in our data set over here. But we can also go ahead and check this on the box plot of the heights if we want to. So these should correspond to the numbers that are like the top, middle, and bottom parts of the box, which I'm just seeing, yeah, they are the same as I'm hovering over them. It's a little bit hard to get my mouse in the right spot. 71. 69. Okay. So that's that part. And then did we have any questions about that? Nope, we just had to do that. Okay, so number 5, in cell 07, which is this first pink one, use the formula %rank.inc to calculate the percentile rank of a female student who is 66 inches tall. Okay, so basically, if we imagine that we are this female student, we're 66 inches tall, and we want to know, well, what percentage of the way through the data set am I? Like, how do I compare to the other students in the class? So we're using equals %rank.inc. That's the formula. Let me scroll over a little bit. And then the first argument there is array. So we're using table 2 again, and then bracket, and then female heights. Okay, close bracket. And now for the second thing here, it's not the percentage, it's actually the data value that you're interested in. So you're going to type in 66. Just type in that number yourself because it's not in a cell for us to click on. And then you see this third argument here that it's suggesting, which is significance. You can just ignore that one. It's like some kind of optional thing. I don't remember exactly what it does. Whenever you see the suggested arguments in the square brackets, like significance here, that means they're optional, so you do not have to include them. So I'll just close there. Okay, and so I'm getting 0.56, but remember that's the decimal form. So we can style it as a percentage if we want to using the number format. So 56%. So if you are a 66-inch tall female student who took this survey, then you are 56% of the way through the list of female heights. So you would be taller than or the same height as 56% of the other female respondents, and you would be shorter than or the same height as 44% of the female respondents. Okay, so now what we're going to do is kind of an interesting thing, which is in cell 08, we're going to use percentile.inc to calculate the percentile of the male heights that has that percentage. So in other words, I want the 56th percentile of the male heights. So what you're doing is you're kind of like finding the matching male height that matches to this female height. So when we get these two heights, the 66 and whatever the male one is, those two students would be the same percentage of the way through their respective genders' list of heights, if that makes sense. So like if we were going to match everyone up like in order, like put the shortest female student with the shortest male student and then keep going like that until the end, these would be the two who would be matched. Okay, so the percentile amongst male heights, we're going to use equals percentile.inc. And then we're going to select the male data. So this will be table 2 again. And then it's bracket male heights, close bracket, comma. Okay, and then for this, you can go ahead and click on that 56% cell, or you could type in 0.56. Okay, and we get 71.84, so like slightly less than 6 feet tall. Okay, so notice here a percentile rank is a percentage, and a percentile is either a real data value or something that could have been a data value. So this is a height. And now we're just going to do the same thing, but we're going to do it for starting with a male height and then moving to a female height. So the other way around. All right, so first I'll do percentile rank of this male height. So for my array, I'm going to do the male heights. So table 2, male heights. Okay, and then comma, and then for X, that's the data value. So I'm typing in 70 myself. Okay. All right, so it doesn't seem that much shorter than 71.84, but it's a really different percentage here. Let me put it in percentage format. So 29%. And then I'm calculating the corresponding female height using the other formula, which is percentile. So percentile.inc. And so for this array, I'm going to use the female heights. So table 2, bracket, female heights, close bracket, comma, and now K is the percentage, so I'm clicking on the 29%. And okay, so a 70-inch tall man would correspond to a 63-inch tall woman. And that was the end of this homework. See you later.